All right, I need you guys to write down what you think a version of law of sines and cosines looks like. Right now, go! Now, the internet's going to see me writing, so that's not going to be a mystery to them. Now, this will be the first/second question on your test for this section, so you need to get this one right in order to move forward in the section. Oh, man, pen, come on.
I love being a nerd.
I'm not a nerd, but I will forever and always rant about black holes.
I hate to break it to you, Taylor. You're kind of a nerd. But that's okay. It's not bad.
As long as you're not a geek. Geeks.
What?
Geeks are
What?
geeks.
I don't know the difference between
I think...
geeks are confused.
Geeks like Star Trek. Oh,
Oh, boy. Hold on.
You got something to say to me?
I'm going to need to pause the video,
Okay,
apparently.
check this out. Okay, listen to this.
Everybody, are you writing down your law of cosines, Daniel?
I'm getting out of
You don't even have the paper.
Okay, so you can liking Star Wars.
Oh, here he
Being a
goes.
nerd's not a requirement. Okay, but you can be a nerd and like Star Wars. To like Star Trek, you have to be a geek.
Jeez, you're so offensive.
No. Geek is a lesser form. No, geek is like technology.
Oh, child. The whole internet just heard you.
We'll take this.
Daniel, I have tens of viewers watching this video at any given time. And they all heard that. Oh my gosh.
I
What if you offended me, Daniel?
Right.
What's your specific response to the lawsuit, not you?
I said that people who watch Star Trek are geeks.
Oh gosh, they're coming for you. Watch out. Alright, so I chose law of cosines version C, but here's the important part. Whatever leg you started with needs to match the angle on the end of law of cosines. Now, the other thing I want to point out to you, this is just the mistakes I see from some kids. They forget that's a subtraction sign, and then they leave off the 2. Did you?
No.
Well, thank goodness. You were too slow. You're too busy, like, throwing shade at Star Trek fans or something. Pretty much just Jacob, yeah. Just cruel. Alright, now for law of sines, I chose the A equals B version, but you could have thrown C in there if you wanted to, but the important part was, and I want you to stick to this notation, the capital letters are the angles and the lowercase letters are the across from them sides. So sine of A over leg A equals sine of B over leg B, or sine of C over leg C. That's going to be the first/second question. Okay? Get them right. Because if you don't got those right, then you're going to have trouble with the next few questions. Can y'all read carefully on numbers 1 and 2? What do they want you to find? The area. So curious, sometimes kids find everything about the triangle except for the area. I don't know why. I guess they can't read. So, area. There are 2 formulas that you are given on your formula sheet tomorrow. We got Huron's formula, which you would use if you have a side-side-side setup. And then you got this other guy, which you would use if you have a side-angle side setup. I suggest you draw the triangle to figure out what you're working with, but it might become obvious. Now, I will warn you on your homework questions, sometimes there's an extra step where you have to use like law of sines before you can find the area of the triangle. Just keep that in mind. Do you want me to do either of these? None of these? But okay, do you prefer Huron's or the other one? Huron's is harder. Okay. So the side one, which clearly is number 2, because you got these 3 sides, the first thing you need to do for me is find what's called the semi-perimeter. So the semi-perimeter is half of the perimeter. And since y'all know you're going to be typing in a calculator in a minute, you might as well just type this in the calculator too. Plus it's a decimal, and that's gross. That's 17.3. So what I do is, since it's already on my calculator, I store it as X, and then when I go to write out Huron's formula, since I stored it as X, I just use X, so there's less typing in my life. So, a couple things I want to point out to you, though, once we get this written down. Number 1, I want to point out to you that I'm writing down what I'm typing in my calculator. That's very importante. Because if you don't write down, that made sense. If you don't write down what you're typing and then you mistype, which we've all done that, I can't give you a decent score. I'm bilingual, clearly. No, that's like one of 4 Spanish words I know.
Spanglish.
I apologize to anyone who knows how to speak Spanish because it's not this girl. I took German. She should teach me some more words. Okay, so the point of that statement was, see what I wrote down? That's what you're typing if you stored. Now, if you didn't store, all those X's become 17.3s. That's more typing. That's why I didn't do it. And then the other important thing I want to point out is right here, that when kids screw this up, they forget that initial semi-perimeter value. That's what happens, and unfortunately they don't write anything down, and then I just get to give them a horrible score. All right, so this comes out to, please label this properly, it's 42.2. The dimensions were in inches, but it is area, so it's inches squared. Inches squared. February. I hate saying that word.
February.
I hate it. I feel very ignorant saying many things, but that's one of them. The area ones, yes, but not law of sines and cosines. Speaking of law of sines and cosines, this mess is a series of questions where I don't really give you any information other than figure something out. You have to decide whether you're using law of sines or cosines. And you also got to know how to set it up. And by the way, what mode is our calculator in? Degree. Okay, cool. What are you thinking about number 3?
Cosine.
It is law of cosines. How do you know that?
Because there's not an angle.
There's no angle, so we couldn't possibly set up a proportion, and it is side, side, side. That's a dead giveaway. Now, because they want angle E, the law of cosine setup is going to start with the leg who's across from him. So, and I want everyone writing this down and everyone typing this on their calculator. It starts off with opposite leg squared equals, now the legs can go in any order because you're squaring them and adding them together. And commutative property says we can do that however we want. But don't forget your law of cosines formula has a 2 after the subtraction sign times the legs and then times the cosine of the opposite angle, which is actually what we're trying to find. So on your calculator, this is one where I'd like you to do this in a couple of stages and everyone practice typing this. You start here and you type in your calculator 21 squared. And then you think about peeling these things away from the angle E, one thing at a time, or possibly 2 at a time. So like right here, the 28 squared, you're going to subtract that over, and you're going to subtract the 26 squared over, and then you're going to hit enter. So you typed 21 squared minus 28 squared minus 26 squared, enter. Now, this is where the mistake happens, so be careful. This is a negative 2 times 28 times 26, and it's all attached through multiplication. So to move these 3 numbers over, you're going to divide them over, and you can just type them in individually. So divide by negative 2, divide by 28, and divide by 26. So you have some number here, and you divide by negative 2, divide by 28, divide by 26. Hit enter. You should have a tiny decimal on your calculator right now. So now you're going to apply the inverse cosine function to that answer. And y'all should get...
45.6
Yes, very good. 45.6 degrees. If you did not get 45.6 degrees, we got to figure out what you're typing wrong. Because tomorrow is not a good moment to ask that question. Cameron, we're on the review, kiddo. This is awkward. You can't hear me. Oh, man. Cameron. Don't throw anything at him. Don't hit him like a fly. We're on the review. Do you have the review? Okay. We were having this awkward moment where I was trying to get your attention, but your ears were all clogged with earbuds. Yeah, I did old lady thing. I called them earbuds. I called them earbuds.
Oh,
They're AirPods earbuds. I don't know. All right, number 4. Number 4, have you thought about whether we apply law of sines or cosines to this?
Sine.
It is. How do you know that?
Because you have the 2 together. Angle and side
You have A.
of A.
You have everything to do with A. Angle and side. Very good. Do you want me to do that one?
Yes.
Okay.
Well, no, it's sine.
Okay.
So it's
That one's pretty...
basic.
All right, let's talk about number 5. We are definitely doing number 5. So, okay. What do you think the answer is?
6.
Interesting. All right, so angle K is 154 degrees. Curious. All right, side P is 22. So across from angle P. And then side K is 10. So you feeling law of sines or cosines? Law of sines? Because you got this. So we're going to set up sine of 154 over 10. And then the only other clue I have is side P, which is good because I need angle P. So we're going to set up the sine of P. Daniel, I know you see it already, don't you? You see something wrong with this triangle, right?
This triangle does not exist.
You're correct. What a bright child. Now, this is where Daniel's very crafty. Why do you think it doesn't exist?
Well, because 154 is
Huge.
100% the biggest angle in this triangle.
Right.
And it is across from the smaller of the two sides that have already been given.
He already
So it
can tell
can't-
this triangle doesn't exist.
it can't
But let's go through like a little math robot who doesn't see that, because that's most kids. And they're going to do their math, right? Thank you, Daniel, for catching that. I was like, someone in here is going to catch it second hour. You're so bright. It was Daniel, the Star Trek hater. All right, cross, multiply, and divide. And then don't forget, guys, here. And right here, you should be wary anyways, because you just hit inverse sine, which we know is the weird thing on our calculator that we got to be careful about anyways. But this is where kids get in trouble. They get an answer. And they're like, my calculator gave me an answer. What did it give you? Did you do inverse sine yet?
Nope.
Okay. 74 point something? 7? Okay. So this is where Daniel again claims superiority, and he's like, look at that triangle, people. Is that going to work? Can you have 154 and 74? No.
Wait, just out of curiosity,
Mhm.
if you were to pretend that sine was of 64 degrees, would you get that same answer?
Say it again.
So, like, because sine you can only go through 90, right? If you go bigger than 90, you would start over, right?
Okay, so are you referring to the sine function or the triangle?
I don't know.
Okay, sine is defined through the entire rotation of 360. Positive and negative, though, is the issue. So, like, if you think about the positive portion of sine, is that what you're referring to, Daniel?
I just proved myself.
Okay.
I had this theory
He's bored. Okay.
as to why
So-
that came up.
That was a trick question, but I'm glad we were able to talk about it together as a class, because this does happen where if you don't recognize that this triangle just is bogus to begin with, and you go through the math like a little robot, and all I asked for was angle P, I got a lot of kids who were like, I got an answer, and you said it doesn't exist. Well, you got to think about the bigger picture of the triangle. This triangle does not exist. It wouldn't close. Okay? It would make a very odd-looking, open-ended
Is it
shape.
possible to draw a triangle that doesn't exist?
Well, it wouldn't look like a triangle. So like this one in particular, it would be like an unfolded triangle with like an open section. Yeah. It would be like when a kid like breaks the toy apart and just yeah, it's not a triangle anymore is the issue. But this feels very theoretical, like you want to make one anyway, so go ahead. All right, number 6. Mrs. Hoffbauer took the liberty of drawing me a triangle, so I'm thinking we need to look at number 6. Let's take a peek. We have triangle A, B, and C for vertices. Angle A is 63 degrees.
That's pretty close to being accurately drawn.
It's not my doing. All right, and then side C is 35. And then side A is 34. It is most definitely sine. And Daniel, are we going to have that same problem anymore?
No.
No, we're good. So we're going to find some triangle business going on here. And we do need to set up law of sines, so let's do that. So we get the sine of 63 over 34. The only other, this feels very reminiscent of the last question. Okay, so the sine of C over 35. So again, on our calculator, we're going to solve it. We're going to multiply these together. You're going to divide by 34, and then at the end of it, don't forget to take the inverse sine of that little decimal you just got. And y'all are finding angle C. Yeah. Anybody have any memories of homework problems past right now? This is the trick question.
Why is it a trick question?
Ambiguous case pops up right now. Did you guys recognize that you had side angle?
I realized.
Okay, the fact... Yes, you had angle side, yes. So the fact that you had to take the inverse sine function to a decimal should trigger, like, this is the trick question. Okay, there's one on your test. You just got to know to catch it. There's no, like, star next to it. I didn't highlight anything. I didn't put a little cute reminder, like, don't forget about the ambiguous case. You're supposed to know it. This is it. So the ambiguous case says that there's a possibility for a secondary triangle where this angle C is actually the supplement to what you originally found. So that should be, I can't subtract, is 113.5. Okay. So now I got to think, is that even possible?
No.
If this is 63 and this is 113.5,
Wait,
that
yeah.
adds up to less than 180, so you still got a little bit of angle to work with. So yes, the answer is yes, this is possible. Now, this question's harder than what's on your test. Your test says find angle C and stop. So you would have to tell me 66.5 and 113.5 if this is the case you have. But this question is a little harder because what does it actually want? Angle B. So in case 1, angle B, and this is not a hard follow-up here, you just got to do a geometry question. Your triangle has a 63, a 66.5, and what would be the third angle? Thank you. And in case 2, your triangle has a 63, a 113.5, and angle B would have to be teeny tiny 3.5.
So if it didn't work, like the case didn't work,
Then you just ignore it.
what would
Then the answer would have just been 66.5.
so then how 180 minus
So, like, it usually happens when this angle is a little smaller than this, because his supplement's going to be pretty large. Okay? So, if this came out to, like, 130, when I went to go look at my existing triangle, who already had a for sure angle of 63, when I added those together, I was already over 180 degrees, so I'd cross off the ambiguous case. It wasn't, I didn't have to consider it.
so I was
Yeah, it's confusing. There's a lot of numbers happening on that. So if it bothers you, if you're having a hard time wrapping your brain around it, what you can do is just draw 2 triangles. And they start off the same, right? That red and green stuff will be the same. And then in case 1, you found angle C to be 66.5. And then in your secondary triangle, angle C was 113.5. And you can investigate them, like, separately. Yeah, that's usually what I do because, yeah, you know my mistakes I make. That seems like a place where I'd make a mistake.
Can you just subtract any number or any angle? Or does it have to be the one you found?
To find what, Brayden? I'm sorry.
Ambiguous
The ambiguous case is always the supplement of the one you just found using law of sines. Okay, so whatever you just found, find his supplement and see if it works. Okay. So, warning tomorrow, if you do inverse sine on a law of sines question, you got to watch out for the ambiguous case. There's no warning on the test. There's no star next to the problem. Look for it. Okay? There's one of them. By 2. You'll find 2. Just for fun. Just to prove me wrong. Alright. Number 7. It's law of cosines. But I would only know that after I draw and label a triangle and see that it's side angle side. This is the one that's supposed to be real easy and you type it all in your calculator in one step. Do you want me to do this one? It's pretty boring. You can do it. But moral of the story for your test tomorrow, guys, whatever you're typing in your calculator, I want to see what you're doing on your paper. Because how easy is it to press the wrong trig button? Daniel?
I keep on
I know,
doing
you do it all the
cosine.
I pressed cosine! And you meant to press sine. Yeah, I do it too. It's very annoying. And you think after 20 years of doing that I'd stop, but alas. It hasn't settled yet. Okay. So there's an application section. Sometimes the diagram's there, and sometimes it's not. This is a nice baseball problem.
Baseball.
All right. You don't. Okay, so 90 feet from was home plate to first. So the first baseman had to travel over here to get a ball, and they want to know how far he ran. So this is the X, Can you tell whether you're supposed to set up log signs or cosines based on that information? It is cosines. Yeah, you got a side angle side setup. So law of cosines, you're going to start with the leg across from the angle you're given. So this guy right here is 10 degrees. So we're going to start off with x squared equals, and then legs squared in any order added together.
What's that big square?
This is the baseball diamond tilty. This is home plate.
Oh,
First, second,
okay.
third.
All right.
I'm sorry, I didn't draw like actual baseball things. I didn't draw anything, let's be honest.
Actual baseball
You know, like people and
things.
lines on the field.
For a field.
I bet Mr. Day would have. Have you ever seen his drawings? Like his geometry stuff? It's beautiful.
Yeah.
I should hire him and be like, draw all my drawings for me, thanks.
Yeah,
So
he writes like an engineer.
he sure does. I don't.
His whole family is engineers.
This is a one-stepper on your calculator. Yeah, so you do this. Crank that whole thing, one step on your calculator.
You forgot to square the 120.
Ah, for Pete's sake, I sure did.
That was going to be wrong.
That would have been terrible. Good call. And your answers, especially on applications like this, you should kind of think about your answer and see if it makes sense. So we just calculated that the dude ran 35 feet to go get the ball. This seems logical. If you forgot to square root, you would have got like 1,000. Which doesn't seem logical. I mean, I don't play baseball.
To run 1,000 feet in the same amount of time that a baseball is
Right.
traveling
I feel like he missed the runner in that circumstance.
Probably.
It's an infield home run. Okay, anywho. 35.0 feet. Make sure you're labeling your applications for me. I hate to be picky about that, but I'm going to be. I don't like this question because I feel like it's difficult to understand what they're trying to tell you. There's an angle formed by A, C, and B is 27. This right here is supposed to be 27 degrees. They worded that very oddly. Yeah, I know.
An
Just-
angle formed by tree A,
Uh-huh.
a dry point C,
Uh-huh.
and okay, so it's the angle.
Yeah,
AC.
yeah, where like the vertex is the middle thing. They just worded it strangely, and it's like, there's nothing on this picture other than like a blob. So you know me in drawings. We're not friends. I have to really stop and think about this. All right, so the next clue they give you is angle ABC. So again, vertex is in the middle, is 85 degrees. So that's this guy. And they want to know how far, one more clue. AC is 150. How far apart is the tree to the other tree, which is this guy? I'm going to call it X. Yeah, that's clearly sine.
So you always use sine in English, right?
Um,
Well, if you haven't. Oh, yeah.
as opposed to law of cosines, yeah. That's a good way to think of it. Sometimes you have to find the third angle. The trick is when you have one angle, I can't say like you're always using law of cosines because there's that one ambiguous case style where you are finding the angle. So we got to be careful about that. Hi. All right. This is off of worksheet 26. It's not on your review, but you might want to pull out worksheet 26 considering it's a homework assignment. And we got to go back and dig into our geometry brain. What do we remember about parallelograms, guys?
Or two triangles.
Those are all kind of true things. They're all right triangles. There's two congruent triangles in them. I got you there. Which means that these parallel sides are not only parallel, they're also congruent, right? So the shorter sides, which you should label respectively, and the longer sides are congruent. And then you have two diagonals, long and a short. And you have two sets of congruent angles. Now, what's the relationship between these angles?
They are complementary interior angles.
They are consecutive interior angles, and they are supplementary is the mathematical relationship. They add up to 180. So one of these angles is 39. If you base it just off the picture, one of them is acute and one is obtuse. So this guy right here must be the 39 degree angle, which means this guy is 141 degrees. That's the relationship you have for parallelograms, okay? They want the length of the longer diagonal. So you got to make sure that you're looking at the right triangle before you start doing any law of anything. They want this triangle, which means I'm sure glad we knew that relationship about the angles being supplementary to each other. Law of sines or cosines in order to find the length of this? That's it. Cosine. So on this particular triangle, we're going to set up law of cosines to find x. And it's the kind where you start off with x equals. So this will be the easy one. Good news. Don't forget to square root it, though, on your calculator. I'm going to let you guys finish up that one. The end of the review is the stuff that shows up on the test again that reoccurs from the last test. So while you guys are setting up that one, we got to go back and think about 4.6 in a minute. Some of you were just beautiful on 4.6 last week. And I want you to stay beautiful on 4.6.
Wait, was 4.6 the
Four-
last one?
Mm-hmm.
I was not.
You were not beautiful on that one. So you're going to be beautiful tomorrow, right?
No, I'm not.
Yeah, you are.
I'm not.
Yes, ma'am. Yeah.
So if I finish this, can I take that?
Yes. Yes. I don't know if you have time to do the whole shebang, but some of it, yeah. If you have something up there, like waiting, because you asked for a retake on stuff and it's all ready, you can work on that if you have extra time tomorrow. That's the other reason why we gave you that trig worksheet to pick up today. I know some of you won't be here tomorrow. That trig worksheet is getting you warmed up for Monday's lesson. We're going to start doing trig identities. We start the new chapter on Monday. Trig identities is that fun stuff where you like swap tangent for sine over cosine. You start crossing off things. Get common denominators. It's going to be a hoot. So you're going to love it now. Oh, thanks for the answer. All right. Take a look at your review. These 3 questions are all questions that you're going to need to make a sketch of in the coordinate plane. But let me tell you the number 1 mistake I saw in the test last week. This question. This is what kids told me. No. And then I had to get all salty and say, no, child. So I crossed it wrong.
Negative pi over 4.
Uh-huh. And then I probably drew you like a picture off to the side and I said this, like arc sine is defined from here to here. And that was supposed to remind you that arc sine is only defined from negative pi over 2 to pi over 2. So we don't call that 7 pi over 4. We call that negative pi over 4. So that was the biggest mistake that I saw repeatedly from your class. Don't do that again. Some of the other cuter mistakes I saw. When you travel left in the coordinate plane, is it a positive or negative movement? That's negative. You know that. So make sure you still know that tomorrow. The other thing I saw was some cute things happening on this question. I used the word cute. I don't know if that's right. So you're going to draw a triangle. And they gave you a clue. It says arc cosine alpha, or A. Think of that as alpha over 1, or A over 1. So cosine's ratio, remember, is the adjacent leg over the hypotenuse. So I could label the adjacent leg as an A, and the hypotenuse as a 1. And then y'all could do a little Pythagorean theorem to find me this missing leg, which you did a nice job with. Most of you use the shortcut, finding a missing leg in Pythagorean theorem, is where you take the square root of the hypotenuse squared, and then you subtract the leg squared. So that's pretty boring here. 1 squared is 1 minus a squared. So square root of 1 minus a squared. And then some of you stopped there, which was sad.
There's more.
Because the actual question says what? Tangent. It says, please give me the tangent for that respective triangle. So the tangent would have been the square root of 1 minus a squared over a. So just a couple of things to shore up for this next test on that section. I think you guys, you were right there. Like lots of concept understood. Just calling those negative angles the right things. That was a bit of a difficulty. Hey, who else is defined from negative pi over 2 to pi over 2 non-inclusive this time? Tangent. And where's cosine? Arc cosine defined? 1 and 2. Yeah, 1 and 2 only. Very good. Be careful on that first question on the review. When you sketch this out for me, because this is not a unit circle question, you're going to have to draw it. Where should I be drawing it? Quadrant 4. Very good. And this is what I mean by really adorable things you've done in the past. The tangent ratio is negative 4 over 3. Opposite over adjacent, right? What is this? Yeah, how do you know that's the negative 4? It's a downward movement. So on the coordinate plane, that is negative. And then this happens to be a nice Pythagorean triple, 3, 4, 5. This one is not, so you gotta do a little gross radical work here. But remember, this question, Daniel, doesn't want that. What does it want? It wants sine.
I still don't.
You don't get this? The picture?
No.
Oh.
I get that thing.
Okay. So this just asks you to figure out where exactly are we looking in the unit
Right,
circle.
well,
So we did that.
I got that one. The one that I kept messing up on was where it's asking, it would say like sine tan 0 or something like that.
Yeah, you're not a fan of that.
No.
Okay. Well, we can talk about that. Let's just make one up. Sine arctan or arcsine or what do you want? Arcsine tan 0?
Yeah.
Okay. So this would be a very tricky question because it would be first asking you the tangent at 0. This is an old question, this one.
So it's not asking
So the
where is
tangent,
tangent 0?
when it does arc, yes. This is an old question. So this one says, what is the tangent at 0? So I think about my unit circle. Here's 0, right? This ordered pair is 1, 0. What is the tangent at 0? Sine over cosine. So 0. So this says 0. So now this question says, where is sine equal to 0? Yeah, that one's 0. It's a weird question, but yeah. I know. These, you know how my brain works. Like, this is a dyslexic's worst nightmare. So, like, So I've had to combat that by rewriting it. So anytime there's an arc question like this, sometimes physically and sometimes just in my brain, which is a dangerous place to be, I rewrite it like that. And that helps me. If it doesn't help you, I'm sorry. Alright, anywho. What else you got? Any thoughts? You want me to make up another one where I try to trick you? No, you guys make me very anxious talking about space and universe and time continuums. And, oh man, bye. Peace out. Hope we all make it to